I'm going to start you off with a parent graph called the inverse function parent graph. And I'm going to preface this with, this parent graph is one in which if you don't want to use the parent graph and you want to use what I teach you tomorrow, or even later this afternoon, you can do that as well. So I'll teach you critical movements for this parent graph, y equals 1 over x. But if you don't want to learn the movements, which are really simple on this one, no problem. Right? This is called the inverse function, y equals 1 over x. And if you were to plot some points for this graph, tell me some points that are on this graph. 0, 0 is not on this graph. One of the few parent graphs where that's true. 1/4, 1/4 is not on this graph. 4 and 1/4 is a point on the graph. Yeah? Really? 1, 1 is on the graph. I heard. 2, 1/2.
Oh, yeah.
This is the parent graph. Y equals 1 over x. Good. Good.
0 and 1.
Nope.
0 and undefined.
So, what's that?
Never.
Eileen's this morning.
What'd you say? It's never going to touch this y-axis. So what do we have there? We have an asymptote. Tell me another point. Nope. 1/2 and 2. Very good. 1/2, 2. 1/3 and 3.
1/4 and 4.
Nice. I think we've exhausted these. So the graph is going to look like this. It's going to come down along the asymptote. Ooh, double asymptote. Where's the other asymptote? So what's the equation?
X equals 0.
No, that's what this one was. Good. Sick in a good way? Okay. Come on, boys and girls. Where are the thinkers? Wait, what? Why? Who? What?
Soft.
Uh-huh. Better known as 1, yes. 1 divided by 1, 1. Nice, my guy, that's not? On what?
It's going to be like 4.
Well, it can't be 4 1/5. Why would you think that if you plug in a 4 here that you would get 1/5?
No, I'm trying to put in 5 for y. And
Oh, don't put anything in. Don't put anything in for y. Well, you can, but why would you want it? That's pain and suffering. You like pain and suffering. They call those people masochists. Put in a 4. What do you get for y?
Put in a 5. I don't know.
Yes, you do.
Put in a 4 for y.
No, never put anything in for y.
Put in a negative for y.
Put in a 4 for x. What's y?
Y.
Put in a 4 for x. What's y?
4. 1/4.
Yes?
How are you getting
I'm making it up.
Put in a 4 for x.
And what would y be equal to?
1/4.
Right. 4 1/4.
Okay.
5 1/5, 6 1/6. I thought we were through that. Are you good on that? Don't be plugging in for why. That's like touching the electric fence. You don't want to do that.
Okay, I understand.
Pain and suffering. You like doing that.
No, it's
Haven't you seen Jurassic Park?
yes.
That's a good one.
Come on, what else?
It's only in one bucket.
-2, -1/2.
Oh,
-1.
-1, -1.
-3, -1.
Nice.
Yeah, so it's right.
Wait, this is negative?
Negative a half.
Look, they mirror each other.
Yeah, you just keep
I
calling.
did. How did you point that out?
Ooh, that's cool looking. I like it.
Hey.
Okay, first talk.
You tell me.
So, what?
It's like the
Don't touch my asymptote.
What?
says it right there.
What do you know what it is?
I'm not touching you. Right, asymptotes. These are two asymptotes, a horizontal and a vertical, and you cannot touch them.
And they mirror
And
each
then
other.
the anchors.
What's that?
They mirror each other.
They're who each other?
They mirror each other.
They do. This graph itself is called a hyperbola. Hyperbola or hyperbola.
No,
What?
my teachers get my quotes from Brian right now.
I'm so sorry. I'm going to have to brush up on your Brian Reagan quotes. Read who we thought. I don't even know what we're talking about. I can't even fake it. Sorry. He must be some cute guy or something. What?
No, he's like really good.
Okay.
Have you like comments actually?
I know. Who is this guy? Oh,
Brian.
okay.
Never heard.
These come in pairs. There's two of them, one in each corner, and they're called hyperbola. There's a vertical asymptote and a horizontal asymptote. What you need to be able to find in these, or in this situation, is what are the vertical and horizontal asymptotes. Now, like I said, we can skirt around this and say, well, I really don't want to learn the parent graph, and I'm going to teach you how to find vertical asymptotes and horizontal asymptotes in general. Okay? Now, what I need you to understand here is what happens at infinity, because that's what asymptotes are all about. And I know that I have done I have said this statement before about asymptotes. You cannot touch them. But you can. Okay? Asymptotes that are not vertical can be crossed. And they can be crossed in this picture. They can't be crossed at infinity. An asymptote is what happens at positive and negative infinity. And we're going to talk about that more in the next few minutes.
Wait, why can it cross the horizontal but not the vertical?
Because that's a good question. Let me put that question on hold and make sure that I address it, and I do address it. But there's a huge difference between a horizontal and a vertical asymptote. Okay? This is your parent graph, y equals 1 over x. It is called a hyperbola, and I only care about 2 points. From the origin, right one up one, and left one down one. From the origin, right one up one, and left one down one are the only 2 points you need to know. And then from those points, you push your asymptotes.
So from that, then
From that, then we. Really? That's exactly right. From that, then we. So that'll be easy for everybody.
so from that,
Then we, right.
then we do 1 over x.
No. This is the graph. From the origin, We have a vertical asymptote, horizontal asymptote, and from the origin, right one up one, left one down one, and then draw your graph.
So the line keep from color side equals 1 over x.
That's what we're graphing.
You just did it with different numbers.
Yeah.
Nope,
Because so graphing the.
I didn't do it with different numbers. What were the different numbers? Were they like 2 1/2 and 3 1/3? Did you just duh me? I hope not.
No, I think,
Okay, first of all, I didn't teach you anything, you gave me the points. All of those points that you gave me are on this graph, aren't they? Isn't this the same as what I just did on the previous page? You're the one looking at me. This graph is what we just graphed. Now, as a parent graph, all I'm telling you is, from the origin, you don't need to graph 20 points. We're not making t-charts. I never make t-charts. With that said, except for rational functions, of which this is, and you can use t-charts. You need to wait until I show you how to do that, and we're going to get there. In the parent graph, though, if you know that this is a parent graph 1 over x, and not just a rational, random rational function, from the origin, right one, up one, and then from that point, push this asymptote and push this asymptote, and you'll have the right curve. Left one, down one, and do the same push.
So our origin is where the asymptotes cross now?
Not now, always. This is a parent graph, y equals 1 over x.
Okay.
For this parent graph, vertical, horizontal asymptotes through the origin.
Okay.
From the origin, right one up one, left one down one. Your ha, y equals 0. Your va, x equals 0. Okay? When you make your asymptotes, please put them dotted and please use a different color. I am tired of saying this. If you use a pencil or you use a solid highlighted line, you're going to lose the points. Asymptotes are dotted and they're in a different color from your graph. They're not part of your graph, they are boundaries.
So the both asymptotes don't have to be different colors.
No.
Oh, I thought it was switched. Okay.
If you want to make them different colors, you could, but there's no real reason to. They're not part of our graph. Dotted shows that, and the colors just so I can see it. Okay? I can't see them if you do them in black. If you do pencil on a black, I can't see them. It has nothing to do with OCD. I'm just blind. What? You're going to love to say today under your breath. Miss No Duh to the teacher? Wow. So here's what it looks like with a vertical stretch factor. No horizontal stretching going on here. So if you take y equals 1 over x and you multiply it by something, the 1 is going to change. And that's a, your vertical stretch factor. If you subtract or add to the x, that's your c component, just as always. And then after the function, 1 over x, whatever you're adding and subtracting is d.
Is it the opposite of C?
Has it always been?
Yeah.
No tricks. Dayton, we've been together a long time and you still don't trust me.
Just clarify.
sounds like a personal problem.
It is a personal problem. You think I could have built up a little bit of trust with this ABCD stuff and still. Now, the best thing is the domain and range, right here, domain and range, are exclusive. Okay? They're exclusive. No, you can't. Everything else is okay except for C on the domain and D on the range. If you go back to your graph, the domain is everything except for what? Yes is not a good answer here. What can't the domain be? 0. No. The domain is what value? What values are the domain? The x. And the x can be anything except when x is 0. And the y can be anything except for 0. So for rational functions, your domains are almost all exclusive. And I'm going to say almost all. It means instead of telling me in every domain we've identified so far, you've told me what the domain is.
Because it's like we can cross it sometimes.
I'm telling you that x can be anything except for c. And x can be anything except for d. So there's two ways, and if you be patient, we'll show you what they look like. You can do it inclusively, but you're not going to. You're going to say, this is so much easier.
So the asymptotes aren't always here.
Not if you have a translation vector. When you translate the origin, you're translating asymptotes. Right? I know it's really exciting, huh? This is not how you want to write the function, but occasionally I've seen questions with the D in the front instead of in the back. Just move it right to the other side. Don't mess around with it. Don't try to be creative. Try to make it look like this. You'll be in way better shape. What? Really? Don't whine. It's not becoming.
It was just a comment.
No, it was whining. It's so much. This is easy. The parent graph is y equals 1 over x. The translation vector is 0, 0. The vertical stretch factor is 4. There's not going to be a horizontal stretch factor. And by the way, whoever it is, what the heck? That means no solution, empty set. Whoever's doing that, stop. This is how you write zeros. If you're the one doing that, don't do that. That's bad. Horizontal asymptote, y equals 0. Vertical asymptote, x equals 0. Now the domain does not equal 0.
So it's infinity.
It's not infinity and infinity.
D is the.
Let's graph it first. Let's graph it first. Normally in the parent graph, it's right 1, up 1. We're going to go right 1, up 4. So we're right here. And from that point, you're going to push the asymptote going up. And now don't give me this. It's not doing that. Okay? These are nice, smooth landing of planes. If you're a plane and you get to here and you go there, people will die. If you're a plane and you're coming down and you get nice, smooth curve to the asymptote. Okay, we are not trying to kill people. Okay, this is a nice, smooth curve right over to the asymptote. Why is it so? Aditi's talking in class? What did she say? No. She never talks. What did she say?
How did you get that point?
This one right here? What do you do in the parent graph from the origin?
Right one.
And what does this tell you to do with what you say after the word up?
Multiply by 4.
Multiply by 4. So right 1, up 1 becomes right 1, up 4. What'd you say?
It's a point.
Back 4. Say it again. Back 4. Hi. Uh-huh.
Okay, so do you only do the 1 point or just do the one that's up higher?
That's not a point.
No, because it's like,
There's 2 points. Right 1, up 1. Left 1, down 1. The end.
those two.
That I'm asking you to plot. You can plot as many as you want. We did a ton of them. If you don't want to just do right 1, up 1, you can do right 2, up a half. Right 3, up a third. Right 4, up a quarter. Right? and then you would multiply by 4. So right 4 up a quarter would be right 4 up 1. Right 3 up a third would be right 3 up 4 thirds. Right a half up 2 would be right a half up 8. But all I need is this point and this point.
Okay.
That's all I'm asking for. You can do more, but I don't need you to do more. They will always push the asymptotes in your graph. Yes?
My question was when you go right 4 up 1.
When you go right 4 up 1,
That's the horizontal.
that's not a question, that's
I
an...
said, would you?
Oh, absolutely. But I don't need you to. Yeah, absolutely. Right, Tyler?
Yep.
What's the other point that I need to deal with?
Left.
Left 1, down 1. Becomes left 1,
Down
4.
which is right here. That's it. So all I need from you,
What about the domain range?
I'm just talking about the graph. I haven't done the domain and range yet. So patience thing, still not working.
Is that when the
What?
Something like
I don't know.
Start the question over. So for this one,
The asymptote criteria.
can't be. Has to be an equation.
Wait, why? Because you're an expert.
Oh, sorry, don't get put out with me.
I'm sorry.
But I'm going to take points away if you don't write them as equations.
I wrote it like that. I just didn't say it.
Okay.
But how do you make that curve in, I don't,
We got to work on completing these thoughts. How do you make that curve? I don't know.
and like,
In like complete thought. How do you?
okay, you know how, I guess I can figure it out myself. That's fine. It's okay.
I'm here to help. All you have to do is ask a question.
Okay, thank you, Riley.
Riley's helping.
Circles up at that.
If you're going to write the domain inclusively, don't write this down unless you want to do it inclusively. You would go for your x's. X can be anything, negative infinity, up until you get to 0. And we don't want to include the 0, so we shun the 0. Union from 0 to positive infinity. I know, oh my gosh. Your x values, don't do it. I'm fine with you not doing it, because I'm never going to do this after this example again. Your x's are from negative infinity. We have points with x can be anything negative, all the way up to, but it can't be 0, because x has an asymptote going through x equals 0. And then after we cross that asymptote, x can be anything again, going to positive infinity. Okay? What can't x be? 0. So for my domain, all I'm going to write is all values of x such that we're not 0. That double bracket, full shuns, means anything but 0. Easy. Your range, you could do the same thing for your range, or you could just say all values of y such that y is not 0. It's up to you. You all seem so exasperated.
I'm just tired.
Okay. All right, let's look at one that just translates and doesn't stretch. Just translates, doesn't stretch. Oh, we are really on the cake delay today. Look at this. What's the parent graph?
Y equals
Now be careful on the translation vector on this one.
1, 2.
1, 2. Take the opposite of what's with the x. Comma 2. No vertical stretch factor, no horizontal stretch factor. Now, what's the horizontal asymptote?
Y equals 2.
The horizontal axis.
Yeah, the last time you put X. Wait, go ahead.
It's because
Okay.
Horizontals have to be y equals. Y equals 2, whatever y is. Verticals have to be x equals 1. If you want, you can do your domain and range right now. It's easy. All values of x such that x is not 1. And your range is all values of y
Except 2. Zero arms.
Everybody follow that? And if you don't get that, it'll be, sometimes it's easier to wait and see.
You just take the translation.
I know. I'm not the one who's confused. I know how to do this. I'm teaching it to you, remember? Like you're telling these people, if you are having trouble with this, you're stupid, right? Yeah.
Well, I didn't say it like that.
Yeah, see, I need to be more politically correct and say if you just wait and we'll take a look at it again in a moment. Yes.
But it's something apart.
Oh no, you have to tell me what it is, but you can do it inclusively or exclusively. This is exclusive. You're telling me what x can't be,
Okay, so
which is perfectly fine with me.
okay.
But if you want to do from here to here and from here to here, you can do that too. I would go. Everybody good so far? Who's knowing me? Be nice. I'm sorry?
Is that the asymptote?
When you point at it, I have no idea what you're... Even going like this emphatically doesn't help me.
The two pink dotted cross.
Those mean nothing. Ignore them. All we've done is in blue ink. Are you with me? Great. Sabrina, where do I move my origin to? I didn't hear you. Probably said it. My origin 0, 0, and now I'm going to translate it where? To 1, 2. There's my new origin. As soon as you get to your new origin, what do? Which way? Horizontal and vertical. Put them both in. And they go right through your translated origin. Jane? Oh, that's not a raise. That's working on the one. Ryan, in the parent graph, from the origin, right one up one. And?
Down, left one, down one.
Left one, down one. And then push your asymptote. 1. Make sure you get them towards the asymptotes. Yes, sir.
Would it be okay for the vertical step factor, horizontal step factor, if we just put it in reverse? Is that okay?
You can if you wish. If you want to put ones in here. This list is pre-made. I wouldn't even have it as part of my list if I'm making a key.
Okay.
If there's no vertical and horizontal, I wouldn't even bother with it. But that list is pre-made, so I just throw it up there. Now, if you want to say your domain is from negative infinity to 1, and then 1 to positive infinity, that's fine, but it's so much more writing. You don't need to do that. This is identical to your parent graph. Everybody has just moved right 1, up 2, we're done. Please make sure your graph doesn't look like this. This is what I get from a lot of people in green. That's not going to fly because you're not getting close to your asymptotes. Because you didn't crash. Right. Actually, I would prefer you to land, not crash.
How about crash landing?
No. We good on this? Okay, try this one on your own. See how you get go. This is a little bit trickier. Here, graph. Tell me what we got. We'll do a little bit. The rest of it's not hard. It's just you're gonna not difficult time consuming. Translation vector, Chase.
Translation vector is 1 and 2.
1, 2. Irene, vertical stretch. No horizontal stretch. You want to put a 1, knock yourself out. Your horizontal asymptote, Cole. If you don't say y equals 2, I'll write the y equals in for you, but I charge that. Vertical asymptote, Nelson. X equals 1. Zach, how about your domain?
Anything but 1.
Anything but 1? Tyler, how about the range?
Range, anything but 2.
So shun the 2, shun the 1. Summer, where do I start the graph? 1, 2, your new origin. When I get to 1, 2, Andy, what should I do? Before that. No, there's only one. Asymptotes. Both vertical and horizontal should be done right away. Dayton, how do I get to my points on the parent graph?
Right 1, down 3.
In the other parent graph.
Right 1, up 1.
And then what are you going to do in this graph? Because you have a VSF of -3, right 1,
Down 3.
down 3. And in the parent graph, left 1,
Up 3.
in the other parent graph,
Down 1.
and left 1, down 1 becomes left 1, up 3. Just one question ahead of me today. Push the asymptotes. From that point, just do the best you can. As long as you're not outrageous, you're going to be in great shape on these. We are going to start talking about finding the x-intercepts and things like that. We'll get there. Not critical for us right now. Any questions so far? This is all parent graph stuff. Well, we're going to talk about other things. Theoretically, we could maybe absorb a few more things. That's my goal. Okay, look at this one right here. This graph right here, not a parent graph. It's not our parent graph. Why not? Because why? Nope. Because there's an X on the top. Yeah, but X on the bottom is what it is on our parent graph, right? Bless you. So these, not parent graphs. Okay? Now, we need to talk about vertical and horizontal asymptotes and what this is all about. And we're going to talk, I'm going to show you some ways to find your vertical and horizontal asymptotes. And we're actually going to move away from the example first. And we'll talk about in general, if you have a function in this form, and again, this gets sketchy for me because it only works when you're in this form. So, yes, this is good, but it's exasperating to have all these unique situations for me. And I can't keep it straight, to be honest with you. So, in a minute after we get through here, I'm just going to talk about the asymptotes in general and how you find them. But if you are in this form and you have an x on the top and an x on the bottom, and whether you're multiplying or not, your horizontal asymptote is going to be y equals a over c. Your horizontal asymptote will be whatever the coefficient on the x is on the top, divided by the coefficient of x on the bottom, and it's a horizontal line, y equals a over c. Your vertical asymptote is cx plus d equals 0, and solve for x. X equals negative d over c. But like I said, for me, this is exasperating because there's too many details to remember. I can't remember y equals a over c and x equals negative d over c. It drives me crazy when I have to deal with details like this. Okay? Now, these will work every single time when you're in this form. And the parent graph, 1 over x. All of what we've done so far will work great. But what I need you to understand are what asymptotes are. Asymptotes are limits. They're lines a graph approaches, but it can never reach. And it's what happens at infinity, not what happens around the origin, not what happens in the first plus or minus 100, either x or y. It's what happens as you go to infinity. And this is a hard concept to understand. And I'm going to start with the vertical asymptote because that's easy. Okay? Now here's my cookie demonstration. And if I had a cookie, I would use a cookie to explain this. And I meant to grab one at lunch and I didn't.
Well, can you go grab one?
No thanks. You're going to use your niche.
Imagination.
What is SpongeBob is that?
Will you bring us cookies, Scott?
Probably on Friday. Because I don't think I'm going to be doing it tomorrow. So here's the cookie example, and this is for vertical asymptotes and why it works. So if I'll tell it as a story. Kate brings me a cookie today. She knows I can't eat chocolate, so she brings me my favorite snickerdoodles. I love the snickerdoodle. Big ones from the Cookie Connection.
The connection that's
And she gives me the cookie, and it's the only one we have. And she says to me, because she's a giver, she says, you know, I brought this for you, but I feel like we should probably share with everyone in the class. Okay, I'm fine with that. So we break, it's a big cookie from the Cookie Connection. So we break it up into 38 pieces or whatever we have. And we give each of you a piece of the cookie. Now, when you put it in your mouth, you're going to be able to taste that this is a really good cookie first. And you'll be able to tell it's a snickerdoodle, and that you're going to want more.
take someone else.
But you got to remember, Kate, she thinks about others. And she says, you know, we really should think about sharing. There's a lot of people on campus that aren't going to get snickerdoodles today. We should share with everyone. So we take the cookie and we break it up into 2,300 little pieces of cookie. And you share, we go out and we're going to share with everybody.
What about the birds? Why not give it to them too?
We're not sharing with the birds. This is my story, listen to it. We have one cookie and we're sharing with everyone on campus. You're going to get a little bit of snickerdoodle and you may or may not be able to tell what you're getting. You might get a cinnamony piece so that you get to even taste something. Okay? But again, giver, there's a lot of people, she said, Ms. Lockery, in the world who've never even had a snickerdoodle. We should share with everyone. We could mail the pieces to everybody in the world. All 6 going on 7 billion. So we take the cookie and we broke it into 6.5 billion pieces. Your piece was on your desk when you got here. Hopefully you didn't knock it off and you can go ahead and try it right now. In fact, Kate, I'm giving you my piece back. How much snickerdoodle are you getting if we're taking that one cookie and dividing it among everyone in the world?
More than
Yeah, 1/6.5 billion. It's going to be teeny weeny.
Look at the bright side. At least you get some.
Right, there you go. That's what I'm talking about. Optimism, being a giver. But the reality is, you are getting how much of the cookie? None of it. You might as well say I got nothing, because you got nothing. No, you didn't. The piece that you got is so small, you need a microscope to see it, and you sure as heck aren't going to be tasting it. So we're talking teeny weeny. It's 6 billion pieces from this one cookie. When you have one cookie and you divide it by an infinite number, how much are you going to get? Nothing. That's why the vertical asymptote for your parent graph of 1 over x, when you make this number so big, one cookie divided by infinite means you get nothing at infinity. So at infinity, you might as well say you're right on that asymptote and you got nothing. Okay? The vertical asymptote is what happens at infinity. Okay? Where am I? There we go. So in order to find your vertical asymptote, what we want to know is what's the value of x that's going to make your denominator equal to 0. The vertical asymptote has to be x equals, and it's the value of x that makes the denominator equal 0. It depends on what your denominator is. Okay? For example, if it's cx plus b or x plus 2, it's not 0 that makes this denominator 0. Negative 2. So what value of x makes the bottom equal to 0 is always your vertical asymptote. Okay? To find the vertical asymptote, set the denominator equal to 0. This is your excluded value or values. And I'm giving you a little hint that later on we're going to have more than one vertical asymptote. Value or values for your domain. Really?
See.
Hi, it's David. Hi.
Nice on the phone.
I do. Okay, thanks. Mallory, eat it.
Okay.
Where are you going?
I have a doctor. Companies have a doctor.
Where are you really going?
Doctor's appointment. I'm getting my eyes checked.
Really? Well, that's going to solve some things, isn't it? Okay, good luck. All right, so the vertical asymptote is the easy one to get. The vertical asymptote's easy. Just take the bottom, set it equal to 0, and you're good. Set bottom equal to 0, solve for x. The rest of it's online. Okay, video and hard copies. The horizontal, again, you need to realize this is what's happening at infinity, both positively and negatively. And, you know, it's just a little bit trickier. To determine the horizontal asymptote, look at the top and ignore everything except the term with the highest power. Do the same thing in the bottom. And then reduce. Ignore everything except the term with the highest power. Top and bottom. And then reduce that fraction. Now, horizontal asymptotes honestly can get crossed, but we try not to give you, in this class, situations where that will occur. So don't expect to see a horizontal asymptote crossed. When you go to honors, they're going to get crossed. You're also going to get asymptotes that are slanted. when you go to honors. But in this class, you're only going to have verticals and horizontals. How would you what? Slant asymptote? It's a line. It's y equals mx plus b. They're easy.
How would you do those brackets? The domain and range.
It has nothing to do with domain and range.
Okay.
Slant asymptotes are what the graph approaches. They still go to infinity. What's the domain and range for any linear equation that's not vertical? Reals and all reals, right? So we don't have to worry about that. That won't impact your domain and range. Only horizontal and vertical will. Okay? So let me just show you quickly how to find the horizontal and vertical asymptotes, and this is where we're going to stop for today. Vertical asymptote. Take the bottom, set it equal to 0. What's the vertical asymptote?
Well, x equals 1.
X equals 1. So you take x minus 1 equals 0. X equals 1 is your vertical asymptote. How'd you?
Because, is it because of 1 minus 1 is 0?
Nope. Here's in the bottom, x minus 1. Set it equal to 0 and solve for x.
Okay.
Okay, don't make the bottom complicated. The vertical one's easy. For the horizontal asymptote, cover up everything except for the term with the highest power on your variable. In this case, it's a 4x on the top and an x on the bottom. When you cover this stuff up and reduce, what do you get as an equation? Y equals 4. You're really confused? I'm going to give you another way to do it if you can't get confused.
So when you cover things up, you cover.
I want you to ignore, pretend like they're not there. So on the top, it's a binomial, correct? So I want you to give me only the variable raised to the highest power term on the top. What would that be? The top, the numerator. The variable on the numerator is? The variable is x. So only the terms with the variable raised to the highest power is the only term I want, which is the whole term, 4x. On the bottom, the highest power on the variable belongs to what term? X. Reduce. Y equals 4. Now, honestly, they're going to get harder. You're going to have squares and cubes and things like that. But it's not anything you can't handle. You know how to factor. You guys are good at it. If you get stuck on the horizontal asymptote, okay, and you know it's confusing and you know you're going to be confused because you get confused with this stuff. There's a lot of stuff going on. Here's the easier way to do it where you don't have to think. Everywhere you see the letter X, put 10,000, plug it in your calculator and round to the nearest 10. And that will be your horizontal asymptote. Put in a 10,000 for X. Everywhere you see an X, round to the nearest 10, one decimal place,
Or the horizontal.
to find the horizontal asymptote. 10,000 in for X. If you don't want 10,000, do 100,000. If you want to do a million, even better. 10,000 will work great.
Round to the left.
10 will be fine. Hopefully you won't have to resort to that because the cover-up is so easy. All you have to do is cover up and reduce. You get y equals 4, the x is 10. Now, once you have your vertical asymptote, here's where my statement on the very first time we graph falls apart. Well, it doesn't fall apart, it's what I told you the exception was. We do not t-chart in this class except for rational functions. This is a rational function, variable top, variable on the bottom. To make your t-chart, look at your vertical asymptote. From the x equals, whatever x is equal to in your vertical asymptote, go to the right, 2, 3, 4, and go to the left, 0, -1, -2. This is how you're going to be graphing rational functions, because these are not parent graphs. In order to be a parent graph, it has to be A over x minus c plus d, and more of these are going to be not parent graphs than are going to be parent graphs. Okay. You need graph paper, 1 box, 1 unit. You need a highlighter, and you need something to write with. Pen, pencil, crayon, whatever you're going to be using. So we're going to spend more time with this, but when you put your asymptotes in here, you got x equals 1, and y equals 4. So here's where your asymptotes are. When you plug in the points 2, 3, and 4 into this equation, you're going to find values for y that allow you to plot points. So when you put in a 2, on the top you're going to get 6, and on the bottom you're going to get 1. So 2, 6 is a point on your graph. Yeah.
How many negatives do that then?
You don't. You go from the vertical asymptote. You go left 3 values. So if your vertical asymptote is at 10, you're going to go right 11, 12, 13. And you're going to go left 9, 8, 7.
Okay.
So I wouldn't have any negative values for x in that situation.
So for the t-chart, we go from the origin, don't go
No, from the, oh, you mean when you plot the points?
Yeah.
Great question. These are actual points on the graph.
Okay.
So we're plotting the point 2, 6.
Okay. So
When you plug in 3, you're going to get 10 over 2, you're going to get 5. 3, 5. When you plug in a 4, you're going to get 14 over 3, which is almost 5. So your graph is going to look like this on this side. Now, sometimes you're going to have opposite corners, like the parent graphs we looked at today. Sometimes you'll get this. You'll get another L shape this way. You won't get that on this particular one, but you could. Yeah,
And what does that depend on?
on the equation.
I know, but like what?
It doesn't matter. Just plug in. You're going to go right and left. Whatever you get will show you what it is. When we get to those dates, I promise I'll show them to you, and you'll know. You'll be able to say, "Oh, that makes total sense why we're doing it." I just don't want to steal it right now. Nor do I want you to worry about it right now. So this is what you're supposed to do, but I heard that there was a problem in there where you're not supposed to do, so let me check this. Now